talk about the definition of what it means to be an even function and what it means to be an odd function, and then we'll look at a quick example. Okay. Even functions are defined as functions that are symmetric with respect to the y-axis. Functions that are symmetric with respect to the y-axis. Look over those basic functions on your pink sheet. Can anybody tell me one of those basic functions that appears to be even? Symmetric to the y-axis.
Absolute value.
Absolute value. Excellent. It's a great one. So I'm going to draw a picture of the absolute value function that you would have filled out on your basic function sheet. There's your absolute value function. And it looks like it's symmetric with respect to the y-axis. If I were to fold my paper on that y-axis, one side would map onto the other. Okay. And so in order to think, I'm also going to show you an algebraic test to prove if something is even odd. And so to think about that algebraic test, I'm just going to pick a point over here in this first quadrant, and I'm going to call this point some xy. So suppose xy is on the graph. Then in order for my graph to be symmetric, on the other side of the y-axis, where I had gone x units to the right, I must now be going x units to the left. So that would be now the opposite of x, or in this case, negative x. And also for that point to map onto itself, it would mean that it would need to lie on the same horizontal line, so then it must have the same y. So in order for something to be even, if the point xy is on the graph, then it must be true that the point negative xy is also on the graph. If that point doesn't show up on the graph, then it can't be even, because when you fold the paper, it wouldn't map onto itself. Okay. So here's the algebraic test. If you replaced x and the original function with a negative x and simplified, you should be getting the same y value, which the same y value as the original function we would describe as f of x. So if f of negative x simplifies to be the same as the original function, then it's even. Okay. And that's where your warm-up is going to come into play for today. You're just going to go to the function that's provided for you. You're going to replace all the x's with negative x's, and then you're going to simplify and see if it's the same thing. Now, odd functions have different symmetry. Odd functions are symmetric with respect to the origin. When you are symmetric to the origin in geometry, you might have described this as a rotational symmetry. It's not like folding the paper and it just maps onto the other side. An example of an odd function that's on your pink sheet with the 8 basic functions is the cubic function. Cubic function is considered odd. If I were to rotate that around the origin, it would eventually map onto itself. And so again, just to kind of prep us for our algebraic test, if I had a point xy on my original graph, in order for it to be odd, it would have to have a corresponding point. This one's in quadrant 1. I'd have to have a corresponding point over here in quadrant 3, which its ordered pair would have to be negative x, negative y. so that I go in the opposite direction of x and I go in the opposite direction of y. Okay, and then it will rotate onto itself. Okay, and that would be true for all the points along that function. Okay, if xy is on the graph, then negative x, negative y is also on the graph. Okay. And so that gives us our second algebraic test. This time, if you do f of negative x, and it doesn't come out to be the same as the original, but instead it comes out to be the opposite of the original, that's what the negative in front is for, then you're an odd function. Okay, so if your y value is the opposite. And anytime you have something maybe that looks like a polynomial, so it has many terms, all of the separate terms would have to have the opposite sign. So it'd have to be like you had multiplied the entire function by -1. Okay, and that would be its opposite. So when we do our example on the next slide, we're going to be focusing to start our examples. Notice that both algebraic tests involve this f of negative x. That's where we're going to start our problems, in an algebraic test for even odd. So here's an example. F of x equals 2x cubed plus 3x. Notice that the directions here say, is it even, odd, or neither? So like if you do the test and it's not even and it's not odd, it just doesn't have one of those special symmetries. Not everything is symmetric to the y or symmetric to the origin. One option you have, certainly, is to go to your graphing calculator, type this in your what equals menu, pop up the graph, and check to see if it's symmetric to the y or symmetric to the origin, right? Okay. When I ask you to do this on the test, which is not this Tuesday, but next Tuesday, I'm going to request that you show me algebraically. So you want to focus on your algebraic test here. We're going to test f of negative x. What is f of negative x? Think back to the warm-up. We're just going to sub in negative x for x. I always use parentheses when I make substitutions with negatives. That way it protects me if I need to address those parentheses. Now, right now that doesn't really look like anything. Okay, simplify it a little bit. If you were to take negative x times itself 3 times, so negative x cubed, negative x times negative x times negative x, what would you get? Negative x cubed, right? Because negative x times negative x would be x squared, times a negative would make it negative again. So this is going to be negative 2x cubed. And then that positive 3 times negative x is just going to be minus 3x. And that's what f of negative x is. Now, you'll stop and ask yourself when you get to this point, is this f of x? Blake is saying no. That is not the same as the original, 2x squared plus 3x. So now you ask yourself this question. Is this negative f of x? Yeah. Negative f of x, if I want to do an example real quick, and you may or may not have to do this, would be putting a negative in front of that function, and then you would distribute your negative, and you would come up with negative 2x cubed minus 3x. So I would argue that at this moment, we have f of negative x equals and we're saying this is negative f of x, so it is what type of function? Odd. I'm going to be looking for these pieces when I grade your test next week. Okay. Do you show me that you subbed in negative x? Do you simplify what you have? And then do you make the statement of what that is in terms of our algebraic test? Does anybody have any questions about that?